I would wish, Saktam, you on camera, please. I would wish to first ask you on the topic that you have prepared. Tell Vasudev about your preparation, please.
So I actually I had a doubt. When you said we would be doing peer learning, what exactly did you mean? I mean,
It means
what?
that I will be coining a topic and
Okay.
I'll be into deliberation. That deliberation is called research deliberation. It's not about a monologue that I will be into. Peer learning will take place fortnightly, wherein you are to ideate with a topic which is being coined for the day and come to the conclusion with a few questions which are, I would say, A, the kind of their own, B, there is no unique solution to them, and C, they are open to deliberation as they are having multiple channels of paradox. Okay,
Yes.
so those questions are to be ascribed to the students and they are to, with a hurdle, get to a conclusion, and that conclusion should have substantiation so that we can cement our answer simply. It's an open learning platform where I do partake as a student. Got it?
Yes.
Where we are to come to the conclusion vis-a-vis questions, and those questions are open questions. You can incorporate any person.
It's like based upon your opinions, based
You
upon your
can you can take those questions to whosoever you deem fit will get you a conclusion to it. Okay, later even. And there will be not only, as I told you, it's not going to be just unilateral verbalism from my end. It will be with your partake. So you two are to get me questions, which I am to deliberate. We are all to deliberate in classroom and beyond classroom and get to a conclusion. We are to draw inference of those questions. Got it?
Yes.
That is what we mean by research learning or peer learning. Am I clear?
Yes.
So today, if you are not in this, which you have been, by the way, because I passed on the message long back, but if I take into
Just a couple
if
of
I
hours ago.
okay, fine, I take that into consideration and accordingly will go and try to settle it according to your suit. So if I go and try to settle it according to your suit this class, please be assured on that the class in two coming will have dispensation only by three of you or four of you or five of you. Four of you, I think there will be four or five members. So five members, five of you. I'll be a mute spectator. Clear?
Yes.
So please bring your best questions. Okay? Today also I have to take a few, but towards the faggot, I would say. Okay, so what shall we begin with? Because the plan has been slightly disoriented. So what shall we begin with? What do you want? Which topic we were in? Which topic we were in?
So we were in electrostatics. We
We
finished
were in
the
electrostatic. Which topic?
so potential. We finished the we finished. Yeah, we were in electrostatic potential.
Gradient. Gradient was taken, right?
Yes, sir.
Okay, gradient was taken, and we were in. I presume we were in pressure, electrostatic pressure somewhere. The electrostatic. Correct me if I'm
Yes, sir.
wrong.
You
Electrostatic pressure,
touched on it
sigma square twice
briefly towards the end
absolute.
of the class.
Okay, towards the end of the class, we were in electrostatic pressure. Okay. Now, what about, yeah, there was a question. Yeah, I got reminded of how we got that, those that you did ask, and I asked you to get into deliberation. You went for Mr. DK Ghosh lecture, I presume, right? In search for DK Ghosh lecture, but couldn't figure anything out, right?
Yes, sir. All those files have been taken offline. It's not maintained any longer.
So, do you want me to narrate it to you? How do we get it? Those values which we got, and I asked you to keep on face value at that point in time. If you have gotten, good. If you have not gotten, then I'll go for a short deliberation on it, and we'll get back to the basics. The basic, by basic I mean the organic which you have in electrostatic vis-a-vis 12th grade. Shall we? Shall we take a digress?
Yes, sir.
Okay. So write down taken a shell, and I'm doing the reverse logic over here. See, what I have made you write, correct me if I'm wrong, I took the charge inside of the shell, correct?
Yes.
So let us go by reverse logic. I've taken a shell which is grounded and charge is out of the shell, fine? It'll follow. There'll be no difference in the two except for which one is to be placed where. Distance remains. Okay. So what I have to prove, I have taken a shell, please write it down. Let us take a shell which is grounded. Let us take a shell which is grounded and a charge Q placed at point shown in the figure. Find charge induced and its location. Find charge induced and its location. When I say charge induced class, I'm trying to find center of the charge induced. I presume that part is amply clear to all of you. Where we will concentrate the center of induced charge. Where will it be? That is what I'm trying to focus here. Am I clear, Vasudev, on this one?
Yes, sir, but how do you make the argument that the complex charge distribution in the sphere can somehow be represented with one point charge?
I don't make that argument as of now because it has not been proved by me, right? So I cannot. I'm starting with the premise that there is a charge which will give same arrangement as that what the ground sphere has got. When I say sphere is grounded, then I am of the opinion, be any point on the sphere, it will read as zero potential, correct?
Yes, sir.
So if I get a point charge, wherever it may be, I don't know, but if I get a point, I may not get the point charge. I may get a weird answer, right? So I'm just taking chance that there is a point charge. If I get a cogent value, a value which is acceptable, a value which is ordinate, then I will stand vindicated. If I get an abrupt value, then I would say it is not in our capacity to replace shell by a pointer. Clear?
Yes.
And if you ask that, how do I ideate it? Then what I will say is, I ideated it owing to field lines. If I get a pattern of field lines vis-a-vis shell, induced charges on shell and charge kept outside, I get a pattern. I can draw that pattern, right, dear?
Yes, sir.
And if I get same pattern by placing a charge of certain magnitude at certain distance, then I ascertain my position, but I ascertain vis-a-vis experimental derivation, correct, dear? I'm not showing you an experimental derivation over here. So what I have to do, if you ask me from where did this stem, I will say it is stemming from certainly the experimental deduction. But what mathematics I do have to support, certainly I do have, and that is pretty simple, which is what? I will take charge, I don't know the magnitude of charge. I will keep it somewhere, I don't know where I am to place it. All abrupt, all abstract. And I'll try to find that can I get, because of the 2 point charges, one the organic and the other that I have placed, can I get same arrangement on the surface of shell? By same arrangement, what I mean, can I get my shell every point reading what potential? Zero potential. Getting it?
Yes, sir.
If I'm able to establish it, if I'm able to actualize it, then I'm all in my capacity to say, yes, this is the point charge which can act charges on the shell. Will I be in my capacity or not? I'm asking.
Yes, sir.
That is what I'm trying to do. Clear here? I may fail in my endeavor. I'm not known to it. I'm playing on my hunch, playing to gallery, playing to hunch. Okay? That is what we begin with. Okay. So let us take the scenario at hand. Let us draw for the case. This is the shell that I have taken. Grounded, no charge on it to begin with. I take a charge Q over here plus Q. Okay. Plus Q charge in the vicinity of cell of radius capital R. What will it do is an obvious, you will get an arrangement. Negative charge, more to this side, lesser to this side will be more sparse than this side, of course. I don't know what charge can be taken, so I take charge Q prime. I don't know the nature of charge. Q prime can be negative, Q prime can be positive. I don't know the nature for now. Where I have taken Q prime, I have taken Q prime at certain distance from center. You can argue why not at center. I am open to it. If it is at center, then I will get that distance equated to 0. So I am taking a generic case. If I take at center, it will be specific. So to make it generic, what I say, that let it be at certain distance from center. Let us mark that distance B. Okay, dear. So far, so good. I don't think there is any confusion. Was there?
No, sir.
Okay. Where I'm to find potential? I'm to find potential somewhere. A place which is R1. Let's say this is a point. This is R1 from charge Q prime. R2 from charge Q, and from center you can take it at R from center. Okay, just give it to us. We will write potential at this point, the point, arbitrary point that I have taken. You could write potential at that point as, if it's P, K Q prime by R1, the mod, plus K Q by R2, the mod, right, yeah?
Yes, sir.
Taken? Okay. We know that if we choose the point to be on the surface, if we choose the point to be on surface, then small r will change to capital R. Right? Small r will change to capital R. I'll come to it later. I'm just making it clear to you at this point in time that if we change small r to capital R, then we'll be referring to the points which lie on the surface of sphere taken. Agreement? All on the same page on this? Yes or no? Vasudev Bibha? Ratnam?
Yes, sir.
Please tell me, can you change R1 and R2 and write it in terms of small r? For now, small r, B and capital R. you are in your liberties to use small r, b, capital R. What I seek from all of you, representing R1 and R2 in those terms. If you wish, you can mark this as theta. I don't have any issue. This angle, which angle? This angle. Please do check there. This angle is theta. This is how much to us? B to us. Okay? This total is how much to us? Capital R to us. Okay? Capital R, be clear?
Yes, sir.
They being taken, what you have to do, you have to help me represent R1. You have to help me represent R2. Can you help me represent R1, R2? If you wish to take any distance which you are unaware of, you want to place an alphabet, you are free to do that. Any distance to be represented, as I have done, I have represented this by B. If you feel that you require this, you can take it to your suit, no issues.
So do you want a vector equation or something that gives its magnitude?
No, I just want the magnitude. I don't want a vector equation. I'm writing for potential, I want magnitude.
So you could use the cosine rule between small r
Yes,
and b.
I'll be using the cosine,
Right.
correct. Correct. I'll be using the cosine term only. Cosine
I
formula.
was trying to derive the vector equation, so that took me
No,
down.
no, cosine, you tell me, you help me with cosine, no issue.
So I mean, it's pretty obvious, the application of cosine for R1.
Right,
For
right.
R2,
We'll be getting, what we'll be getting, you can tell me about it. If you use cosine formula, I presume cosine formula is known to Vibha and Shantam. If not known, I'm just writing it down for you. If this is theta, this is A, this is B, this is C, then we can write cos theta as firstly square of the sides making angle that you have taken. A square B square minus C square divided by twice AB. This is how they are related to each other. A square B square minus C square divided by twice AB. I'm to use over here. So tell me, what shall I do? How shall I make good of the uses?
and I'm sorry, I don't think you can represent R2 given the current variables.
We can represent, yes, Vasudev?
I don't think you can represent R2 using RB and small r.
We can add to whichever is required, no issues. Whatever you wish, you can add. Because later the relevance will get lost. When you will change small r to capital R, the relevance is lost. We are to eventuate it to capital R, and what we are to do after all that is an obvious. Since this shell is grounded, what I'll do to potential? I'll equate potential to what? Is an obvious. I'll equate potential to 0. That is what we'll be doing. That is the aim. Okay, dear?
Yes.
So if you want certain variables to be taken, you are in your liberties. You can take this. For example, I think this will serve.
Yes, sir. Then you could use
If I
cosine rule.
take this A, let us take A.
Yes.
We take this A, it will serve our purpose. Because if this is B, then this becomes what to us? It becomes A minus B, right?
Yes, sir.
You can use now, you can get R1 and R2. May I be helped on this now? R1, R2. What will be R2? What will be R1? Let us write it down. Tell you. By using this formula only.
Yes, sir. So R2 would be R squared plus A squared minus
Right
2A.
over here, R2 will be R squared
plus a squared
plus a squared
minus 2ar cos theta.
minus 2ar cos of the angle theta. Okay, this is R2 square.
Oh, yes.
R1 square, please. For R1
Yes.
square, you can take this triangle, correct?
Yes, sir.
Okay, this one, this triangle. For R2, we took the bigger one, the larger one. This was for R2 taken. For R1, we are taking this one. Okay, tell me dear. R1 square. Yes, Vasudev?
R squared plus b squared minus 2ar
R
cos
square plus B square minus 2
br cos theta.
R cos of the angle theta, right here. So VB is what to us? VB is KQ prime. What I bring in now, the one which I was ranting for long, which is what? I have to change what to what? I have to change small r to what? Capital R. So when I change small r to capital R, the first and the foremost argument which I'll be making is Q and Q prime cannot be of same nature. Are you getting it here? How we are extrapolating our reading? Q and Q prime, when small r is changed to capital R, I should read the potential 0, correct?
Yes.
R1, R2, they are positive. K, they are positive. So what conclusion we do get from there? Conclusion number 1, which is what? Q prime and Q will share opposite nature. Okay, Vibha, getting it?
Yes, sir.
First inference which we are drawing. Then we come to what do we get here? So K, we'll write it down. KQ by, this is what to me? R1 to me, this one, second one. So R2 plus B square minus 2BR cos of the angle theta under of the root plus KQ divided by under of the root, this part, r square plus a square minus 2ar cos of the angle theta. Please do check class. Now an important point, of course we have changed small r to capital R. You can change that and you can equate it to 0. Shall we?
Yes.
Potential on the surface, 0. So what we can do? We can say yes, I'm changing small r to capital R here and here, equating potential or summing the potential to 0 owing to it being grounded. Am I clear, Vibha?
Yes, sir.
Okay. Let me do the change over here. This is capital R square now. This is also capital R square. All capital, small being changed to capital. Small being changed to capital. Okay. So R square plus R B square R square plus A square. Okay. To capital R, capital R. Okay, done. Equated to what? Obvious 0. Well, then I have a question over here. Vibha, Saptam, I have a question over here, which is what? The potential which I am getting should be independent of theta. I place an argument over here. Are you protesting or endorsing? Against, for? Potential which I am getting should be independent of theta. Do you agree? Should be independent of theta. Agreement?
Yes, sir.
So if this potential is independent, why it is so? Theta means what? You are on shell. Wherever you go, potential should read 0. Wherever you go, take whatever theta, you're on surface, potential should read, must read 0.
So, but then by extension, they can also say as long as a small r is less than capital R, potential should also be independent of small r.
Yeah, I'll be coming to that. Let us take in turns.
Yes.
Firstly, potential will be independent of theta. What do I get? What is the equation which I get? Please let me know. Potential independent of theta. What shall I do? What equation do I get? It should not depend on theta. So you will relate q prime with q. We can square them. What do we get? A we can get rid of q prime square divided by writing the equation in wholesome first. R square b square minus 2br cos of the angle theta is equal to q square divided by r square plus a square minus 2ar cos of the angle theta. I'm writing in wholesome as I told you.
So we can't exactly see that.
Okay, I'll repeat it out here, no issues. Q prime divided by r square plus b square minus 2br cos theta. Nothing much, I've just squared.
Yes.
Vasudev, okay.
Got it.
Just squared, nothing much. Q square divided by, now the second one is r square plus a square minus 2ar cos of the angle theta. Please do tell. For it to be independent of theta, what shall I do which fetches me what equation? It should not depend on theta, it should be independent of theta. So can we forego whatever is there other than theta? Yes, Vasudev, what say you?
So 1 second. So you could you multiply both sides. I mean, just bring it onto one line, and then you could equate the coefficient of cos theta to 0.
Okay, let's do that. Multiply q prime r square plus a square minus 2ar cos theta is equal to q square, bracket open, r square plus b square minus 2br cos theta. Okay, right over here. Tell me the coefficient, equate and get me a relation between q prime q vis-a-vis AB.
So you get yeah, q squared A is equal to q prime squared B.
Q square is q prime square. Yes, Vasudev, continue please. Q prime square.
So okay, if you've written it that way, you divide B on the left hand side and A on the right hand side.
A divided by B, right?
There's a q squared divided by B, q prime squared divided by A.
So B by A, right?
Yes, sure.
Okay. This is what we get. Please do check class. Okay. Anyway, we were trying to find q prime, so let us make q prime the subject. Making q prime the subject, I write over here. Q prime square is equal to A by B q square. Therefore, q prime, what do we get q prime as? Is equal to A by B q square. Do check. And you have q square, so q out. Plus minus, which one you will take is an obvious, right?
Yes, minus.
Which we have decided already. So we'll go with mathematics alongside physics minus of q. Mathematics says plus minus. We are placing in, pushing the envelope vis-a-vis physics, going for only the negative term. That is the only to gel here well with our experimental arrangement. Correct?
Yes.
Do we get what we did profess the other day?
Yes, sir, but this is only half of the story. What happened to the dipole?
Yeah, half of the story. Correct. It's only half done. We don't know about distance as yet.
Yes, and what about the other dipole that was also placed at
Yes.
this?
Are we coming to dipole as well?
Yes.
Sir,
Yes, dear.
so why did you put the minus in the last equation in the last step? I didn't
We
get
didn't
it.
take plus, we took minus, Vibha, because potential when added will be zero only when Q prime and Q are of different nature, correct?
Yes, sir.
Otherwise, potential will not add up to zero,
Yes, sir.
right? Therefore, we are going with only negative sign. Can I ask for the deliberation over here of anyone, particularly the two of you, why? Because Shaktam was not there in the previous class. That what shall we do after all this?
So the logical next step would be to get an expression for B.
Yes.
Because right now at the, I mean, we still haven't completely solved it. Our expression for Q prime is still in terms of B, which is still an unknown.
Yes, exactly. We have not done as yet. We are getting in terms of A, B, and B isn't known to us. A isn't known to us. We are not aware of A and B. So what shall be the next argument? One argument I did place. It should be independent of theta, which is getting us some relation. Of course, not in total. We didn't get to the end of it. What can be the other relation, Vasudev?
So is it the one I suggested earlier? Potential inside the space 0.
Yeah, potential will be zero. Agreed.
Yes,
That's what we are working on.
Yes,
But
so
we went beyond that. We have began with the premise that potential will be zero. We went beyond of it by stating it will not depend on theta. We got a relation. What do you suggest after of this?
So if you restrict R to be smaller than capital R.
Small r to be?
Smaller than capital R. So basically you're only considering points inside the sphere.
Firstly, the arrangement that we are in Vasudev will not work for it.
What's that?
When we were inside, what did we say? Outside will not work, correct?
Okay, so we basically what we're deriving is only for the outside.
Yeah,
So
my charge is outside.
Alright. So
when we were inside, what did I say? That whatever we are writing is valid for inside of the realm. Out of the sphere, it will be alienated from what changes or how it is being induced inside. Outside will be uniform, right? Similar interpretation goes for this case.
Okay.
If I'm inside, it's going to be a different story altogether.
Okay, so we can't go inside. Well, not a lot of other places left actually. I mean, we've already done the surface.
Can I place the other argument? Which is, can we focus on r square plus a square and r square plus b square for a change? Anything related to the term that we have left? And the term that we have left being r square plus a square and r square plus b square. Some spunk expected of you. What about them? I told you that will be deliberation at least towards the fag end, right? Let us actualize it. I'm in a discussion with you, open discussion. This is beyond IITJ syllabus, no doubt about it. But this is very much within the realm of Olympiad. Because we are deriving theory. Theory based on experiment. One relation we got, it should be independent of theta, which we are all in agreement. I want you to shift your focus on the term which are there with us. Independent of theta, theta is gone. Independent of theta, theta is gone. What are we left with then? R square, q prime into r square plus a square and q square into r square plus b square. Agreed or not?
Yes, sir.
And we know what relation q prime shares with q. Place it.
Oh, yeah, sure.
Simple.
All right.
So forgo this term, this term left, place q prime as we have gotten over here.
Yes, it looks like you might actually be able to get an expression for p out of this.
Can we get now?
Although you might have to solve a quadratic.
Maybe. Check.
No?
I mean odds with, maybe. I'm not sure. Actually, I'm keeping my cards very close to chest.
Yeah, you will get a quadratic.
Again, you know how to solve it, isn't it? There is no challenge to it. And as was required, what is the time, please?
It's 9:30.
9:30.
Yes, sir.
Yes.
As was required, Vasudev, there was, as was required, Shraktam and Vibha as well. I wish that I get at least one or two questions from any one of you on the topic of your choice. I'm opening the cards to choice. Though I said that probability should be, if you have good question on probability, if you have good question on PNC, we can get into deliberation. You can let us know. You can let the class know. If not, whichever topic you want, a question can be taken.
Yes, sir.
By you, not me. Please start. We'll start with Vibha. Vibha.
Should I ask questions or should I like doubts?
You don't have to ask and explain to us. You'll have to first ask. If we are able to solve, good. If we're not able to solve, you'll have to explain it to us.
So it's kind of like
This is an exemplary which is to be taken by every institute, you know, and there used to be markings on this. You are being called on board, and this is a usual practice, by the way. Let me tell you, you are being called on board. Students are being called on board, and they are being asked to take a 15 to 20-minute class on topic of their interest. And I'm referring to the Premium Institute of IIT. There we have this arrangement. Tell ya, Vibha, you'll begin with. Shaktam, please be on camera. Vibha, begin with.
Sure, I don't know which. So
Shaktam, please be on camera. No, Vibha, this is not. You need to be. You have been given ample time. There is nothing that you cannot. There is nothing that you have to flex your muscle over here. That how I gave us such an easy task. They were all able to sail through. Where do I stand? I could not present a difficult question to class. Nothing of the kind. Nobody is going to judge you. Okay? Quickly, please. Don't take time of class. Quickly. Quick, Vibha. You don't have a question on all this while that you've been studying. This is your how many 14th year of study going on. You don't have any one question from your 14-year career of study. Which topic? Quickly.
Sir, I don't have any questions, sir. I don't know how to.
This is the answer. No. I will not accept this. Sorry. This is not accepted. Firstly, you need to be a sport and you need to be able to take with grit and gumption the challenges. This is not done. Okay? There are people there who don't qualify 2 prelims and then top the IS examination, you know, UPSC. You should have that ambition and the tenacity. I'll come back to you. I'm not going to let you lose. Nobody over here. Please tell me. Yes, Vasudev, what about you?
So give me a minute. I actually compiled a bunch of questions which I found interesting.
Okay. Saktam, do you have any for now? Ready with you, Saktam?
Yes, sir.
Could you please switch on the light, Saktam? You're not visible. Your face is not visible.
Switch on the light in front of me. Not that.
Okay, are you ready, Vasudev, with question?
So just a second. I've never been asked to come up with a question and prompt before.
Saktam, please go ahead with yours. Please dictate the question if you have any good question. Topic that you'll be taking. Stabilize your camera, Saktam. Yeah. Should have been prepared, Saktam, with stabilizing of the camera. Do you have any, Saktam? Who is ready?
Yes.
Okay.
Ready.
Whosoever is ready, please go ahead. We're losing time of class. Who is ready? May I get someone who is ready
yes,
with the
sir.
question?
I think I might have got an interesting one.
Okay, good enough. Okay, please present.
Present. It's just a second. I think you might have heard of this. It's this thing about a sphere which is rolling on the ground. It's undergoing pure rolling, and you take a certain point in that sphere. You have to compute the actual distance that point covers in a given
one
amount
complete rotation.
Yeah, this is value for I think 4 hours or something.
Are you aware of what it is? It is 8 hour, not 4 hour.
Okay, 4 hour maybe for a half rotation.
Yeah, it will be 8 hour, and that's how you do. You have to write x coordinate. You have to write y coordinate. X coordinate will be r theta plus x theta. X coordinate will be r theta plus r sine theta. Yes. And y coordinate accordingly will be r plus r sine theta, r cos theta, r plus r cos theta. Depending on where you are taking. Can you solve it, please? Yes, please.
Yes, let me try. Just a second.
Question being, write down, class. There's a point on the surface of a rolling wheel. There's a point on the surface of a rolling wheel. As there, I presume. Find distance traveled by the point in one complete rotation of the wheel. Find distance traveled in one complete rotation of the wheel. Vasudev is executing how to find the total distance and what will be the path accordingly can be gauged. This is the wheel he has taken.
All right. So okay. Let's just okay. So let's assume this is the point A, right? And we are trying to determine the distance it would travel in a one complete rotation. So ultimately, the way I see myself solving this problem is to get a parametric equation for the coordinates of A. And then ultimately you can plug it into the line integral, right? So you can once you get its parametric coordinates, then you could just do under root 1 plus dy by dx whole squared dx, integrate from whatever to whatever. So I mean, yeah, that's what I see myself doing right now. Okay. So if I could take that as a center, I would first have to choose a coordinate system. I'll take this point, not fixed to the sphere, but fixed to the surroundings. I'll consider that my 0, 0. Okay. So from there, the point starts here. Okay, so if this radius is r, okay, I'll also have to decide how I'm going to be measuring my angles. If this is at some random point, the position where that white point is with respect to this circle of the sphere, I'd like to call that angle theta. Okay. So initially theta is 0, and this point also hasn't moved, right? So if it is undergoing pure rolling, we can relate the velocity of that point with the velocity of the sphere. Right, we know that v is equal to r omega. I think I choose a better color for that. Yeah. So you know that v is equal to r omega. So for now, so I'll assume that the sphere is spinning with a constant angular velocity of omega, and from there I can also say that it's moving forward with v is equal to r omega. Yes. Yeah. Yeah. Okay. So I can say that. So the position of the center of the sphere, its y position isn't really changing. We just need to worry about its x position, and initially it's at position 0. So if it is going with this velocity, then it should be r omega t, 0. Right. So if I call this something, it doesn't seem like a nice name. I'll call it c for center. So if we say c is that, and relative to c, we can get the coordinates for a. Yes. So we can say right now that a would always be you'd also have to shift it. Okay, no, we've taken that as the center of a coordinate system. So we can just and initially, if we want to consider this angle as theta, with the actual angle we'd be plugging into our trig functions. That would be so we are taking this side as positive. That's actually opposite to the convention. So we'll actually be doing minus pi by 2 minus theta. So this would be the angle we are plugging in to any trig functions we use. I'll just call that phi. Okay. So right now we've got our angle, right? If this is theta, then this would be phi in a manner of speaking. So we can say that those coordinates relative to the sphere are described by r cos phi and r sin phi. And if we want the position of this point relative to the surroundings, we would just have to add the both of these up. So the position of point A with respect to the surroundings, I'm a bit sloppy with respect to notation, but I guess that'll do. You're doing quite good. Yeah. So we could say r cos phi plus r omega t r sin phi. Yeah. So I guess yeah. Okay. So wait, this is and then we can also replace theta with what we know is going to be omega t. Right. So we've also gotten theta, and as a result, phi as a function of t. So maybe we can replace these with their equivalent simpler trigonometric values. So we get r cos. So we get minus phi by 2 minus omega t. A cos of a negative value is the same thing as cos of the positive value. So we can just say phi by 2 plus omega t plus r omega t And here for sine, we can't do that. We'll have to take the negative out. Sine pi by 2 plus omega t. Yes. So, I mean, yeah, we could simplify this further. Cos pi by 2 plus omega t. I mean, if you think about it, omega t plus pi by 2, that'll be a negative sine of omega t plus our omega t stays there. And sine omega t plus pi by 2. Well, that's just cos omega t, no sign changes that.
Right.
Oops. Okay. So
You get
yeah,
coordinate vis-a-vis
so this is
surrounding, you say, or the laboratory frame, you say, right?
the surrounding.
lab.
Yes, this is the parametric coordinates of a head.
Yes, these are the
With
parametric
respect.
coordinate. They are in time. Correct.
So now we just need, so we know that we have to take the line integral of this from t is equal to 0 to t is equal to whatever time we please. So I think if it has to do a complete revolution, right, so it would have to spend 2 pi by omega time to get that. So t is equal to 0 to t is equal to 2 pi by omega. Okay, so, well, this is the formula I know. I'll just write down the formula for, I know that the length or the arc length of line is given by the integral of the square root 1 plus dy by dx whole squared dx. Okay, so right now we know that
basically dx square plus dy square under root.
Yeah. Pythagorean theorem modified a little bit to work.
Yes. Let's got it. Yeah.
So y is equal to negative r cos omega t, and x is equal to negative r sine omega t plus r omega t. Right. So, well, we have to find some way of eliminating.
Okay. Yeah. Yes.
Or maybe we don't. Okay.
dtt will be required because
maybe we can just implicitly differentiate both sides of this.
Yes.
And then take dy by dx.
Yes.
Okay, I think we can try that. So if we implicitly differentiate both sides of this equation right here, we get dy is equal to negative r. Well, the derivative of cos anything is negative sine, and then we'll have to apply the chain rule again. We'll just do it aside here.
Yes.
So cos omega t is negative sine omega t, and that of omega t is just omega.
Okay.
And I suppose we could do the same thing for x. So negative r stays outside. Okay. So if you take r outside, you get sine omega t plus omega t inside. Now, so sine omega t is cos omega t. And, well, omega, because of the chain rule, plus omega again, because of the differentiation of omega t.
Okay.
So, I mean...
So this part now, I would say that all of you are to see to the end of it. He has very well explained, very eloquent and loquacious, and he did write with complete legibility, good electric, I would say good electric, and not only good electric, he was very articulate in writing it down. He wrote with clarity, complete clarity. So all praise, but we will be evaluating it. I get back to at least one question from the rest of you. Quick question, just question. We'll not be able to discuss it today, but a question which you can point to the class. Yes, please. And I want with the same clarity, the clarity with which Vasudev did dispense. Yes, the question, please, quickly. Shaktam, Viva. I want the question now. Enough time. Shaktam, where are you? Shaktam, where are you? You're not on camera. Yes, you have a question, please. Time is up, Biva.
Sir, I have no questions, sir. I don't know how. I don't know
Biva, if
what
this
I
is the case, then I'll not be incorporating you. I'm sorry. If you'll come up ranting the same and you help bend on not presenting a question, I'm sorry. This is not the way classes are taken over here. Please get it upright, straight up front. You've been allocated time. You're supposed to get question. Am I clear? Else don't join. Don't be facetious. And don't trivialize it. There's a process and that process to be respected. I presume I'm getting you loud and clear. Am I?
Yes, sir.
Yes, please, Shaktam. Final question.
In this question, we'll take a 15-sided polygon. Then we have to find a number of triangles with no side common with the side of the polygon itself.
Are you able to hear?
His voice is a bit muddy.
Okay, just a minute. Please repeat, Shaktam. Repeat, Shaktam.
We are taking a 15-sided regular polygon, and we have to find the number of triangles you can make out of the vertices of these polygon, such that no side of any of these triangles is common with any side of the polygon.
Did you get it right, all of you?
Yes, sir, I heard him.
Please repeat, Vasudev. What did you hear? Shaktam,
Sir.
cross-check.
So he's talking about taking a 15-sided polygon, and you've got to find the number of triangles you can make of its 15 vertices, such that no side of I think what I heard was no side of the triangle must must share a side with the polygon. No triangle should share a side with the polygon.
I
That's
think
what
he's
I heard.
right. Shaktam?
Yes, sir.
Okay. Shaktam, repeat once.
There's a 15-sided polygon, 15-sided regular polygon. We have to find the number of triangles you can make with its vertices such that any of the triangles have no side common with the side of the polygon.
Okay. So we leave with this question, class. We'll get back to it. Please do solve. If you get right away, get me know the answer to the quickest. Okay?
Yes, sir.
Vasudev, will you try? We want to buy some time.
So this is pretty standard question in combinatorics.
Okay, then tell me.
Okay, so you have a 15-sided polygon, right? And you want to find the number of triangles, or all the triangles which do not share any side with it. So I think you can do this using the principle of inclusion and exclusion. So first, you consider all the triangles that you can form using these the 15 sides of the polygon, and as you make.
So what are the total number of triangles? Tell me first. All the triangles.
So considering you're not rotating this polygon in any way, and every triangle is unique in a certain fixed frame, it would be 15C3. 15 choose 3. You can choose any 3 points from 15 points to make a triangle. 15C3.
Are you in agreement, Shaktam? Total number will be 15C3?
Yes, sir.
Okay, carry on, Vasudev.
Yes, so now you've got the total number of triangles that you can have. Now you want only the triangles which do not share a side with the polygon. Yeah. So you have to subtract them out, right? So first you'd have to subtract all the triangles that share one side with the polygon, right? And the way of doing that is also pretty standard. First you choose one side, so to say, because the side will share. So that will be it's 15 points. It's 15-sided polygon, 15C1. So that will be 15C1. So that will be choosing one side.
Is it correct, Shaktam? 15C1.
Just choosing one side. Just choosing one side, and then you have to choose the other point which it's connected to, because you've already taken 2 points. That's 15 minus 2. That's 13. And among those 13, you'll have to choose one. So 13C1. So 15C1 times 13C1 should get you all of the triangles.
15C1, please come again. 15C1.
15C1 times 13C1.
13C1 will get me all with one side shared.
No, not necessarily one. I mean, this can even have it while sharing two triangles. It can share one or two sides of the polygon.
So what is the answer that you're concluding to?
So wait, 1 second. So it can share one side or two sides. Yes, sir. So inherently you've overcounted here, right? Because when you've considered one side, and you might have considered this point here, right? One side here, this point here, or while you're counting somewhere else, you would have considered this side and this point here. So you've counted all of the triangles that share two sides with the 15-sided polygon twice. So you'll have to subtract them once. And well, there are only 15 ways you can have a triangle share two sides. So my answer would be all the triangles that all the possible triangles minus
15C3.
That's 15C3 minus 15C1 times 13C1 plus 15.
Please figure it out, Shaktam. 15C3 minus, please repeat, Vasudev.
15C3 minus 15C1 times 13C1 plus 15.
Did you write, Shaktam?
Why plus 15?
That's because we've overcounted, right? Because when we did 15C1 times 13C1, I explained it. We've overcounted all the triangles that have two sides in common with the polygon. We counted them twice, essentially. So we need to offset that. So we subtract them once, so we count them only once. We counted them twice, so we subtract them once. I hope I'm clear. I mean, this stems right out of simple inclusion-exclusion.
I presume Shaktam has got answer to his question. Doesn't seem satisfied. Where's Shaktam? Why is the face dull?
It was done a different way when I was solving it and got a different answer.
Okay.
The answer being different. The answer is not an agreement or what?
Not an agreement.
How's that? How did you do it?
Yeah, how have you solved? Please explain.
The total number of triangles till that point is 15C3.
Okay.
Now the total number of triangles will be equal to the ones with one side common plus the two side common plus the no side common, which we still have to figure out. Now for one side common, let's move away from the question. Let's take an n one. Let's take it with n sides. Now if you're taking one side, they have already considered two vertices. You can make a triangle with any of the vertices barring the ones adjacent to those two. So there's A1 and A2. You can, other than A3 and A4, you can make a triangle with all of the other vertices.
Okay, so you're excluding the ones which have two sides right in this step.
Yeah, so one side can make n minus 4 triangles because you're not considering 4 vertices and you're making triangles with the remaining n minus 4 vertices. And these triangles will be repeat, and you can repeat this at n sides. So one side common, you get n into n minus 4 is the standard formula. Now if you look at two sides common, logically, if you take any two sides, let's say P1, P2 and P2, P3, you can make one line connecting P2, P3 to make that triangle. Similarly, if you repeat this n times, because for every time if you let's say 50, you get 1, 2, 2, 3, 4.
Breaking or what?
So he is. Now he's frozen.
Shaktam, could you please come over here? Why you should have kept the camera? You should have kept the charger. I think you're frozen, Shaktam. Is it understood, Vasudev?
Yeah, so he didn't really get to saying his complete solution, but I get a general idea of where he's going. And I still feel both of us should get the same answer, regardless of the different methods.
Okay. So your answer being noted, I presume. Let us verify, and accordingly we'll get back to it.
Yes, sir. I
We
mean,
can revert on this.
my
We have
common
a short-
is a bit rusty. So there's a small possibility I might be wrong here. I'll look
You
into
can
it
work
again.
it out. You have 5 to 10 minutes. You can work out and send it to me on WhatsApp. No issues. We'll
Yes, sir,
share.
sure.
We'll share in group.
Yes, sir.
Share in group.
So which group? The ones that?
The ones that we are in, yeah, the WhatsApp group.
The 2010 physics read or
Yes,
something?
yeah, 2010 redo. Yeah.
Why is it called
Share.
that?
Sure, because 2010 was the year I got only a rank 1 and 2. Never repeated after.
That makes
And
sense.
when you don't repeat, then the general tendency is to say that it happened in fluke. So that is Mark Twain moment. Let's see if I get a repeat this year. I'm hopeful 2024 will see a repeat with Vasudev or Vibha or later Shaktam.
Yes, sir.
There are a few more. When they are in, I'll name them as well. Okay, thank you for now. Thank you. You send me the
Thank you.
working, fine, Vasudev, we'll verify.
Yes,
We'll check the veracity and get back.
Yes, sir. Get back.
Okay,
Thank you,
bye,
sir.
take
Night.
care.